Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the Marketing ROI Optimization Engine, the system that automatically allocates marketing budgets across channels to maximize return on investment. We'll cover how platforms like Google Ads, Meta Ads, and enterprise marketing clouds use machine learning and optimization algorithms to decide budget allocation in real time. Whether you're preparing for a senior engineering interview or building marketing optimization systems at scale, this one is for you. Let's get into it. Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the Marketing ROI Optimization Engine, the system that automatically allocates marketing budgets across channels to maximize return on investment. If you have ever wondered how platforms like Google Ads, Meta Ads, Adobe Marketing Cloud, or enterprise demand-side platforms decide how to split millions of dollars between search, social, display, video, and offline channels in real time, this video is for you. We'll walk through the functional requirements, non-functional requirements, system architecture, end-to-end user journey, core models, low-level design, and the trade-offs that come up in a senior system design interview. Whether you are preparing for a FANG interview or building marketing optimization systems at scale, let's get into it. Here is the core problem. A large enterprise has a $50 million quarterly marketing budget spread across Google Search, Facebook Ads, LinkedIn programmatic display, connected TV, email marketing, and offline channels. Each channel has different attribution windows, conversion delays, seasonality patterns, and diminishing returns. The marketing team spends weeks in Excel trying to allocate budgets manually, but by the time they adjust spend based on last month's data, market conditions have already changed. Competitors are bidding up keywords, seasonality shifted, and the optimal allocation has moved. The business needs an automated ROI optimization engine that continuously ingests performance data, builds predictive models, and reallocates budgets in near real time to maximize total ROI, while respecting business constraints like minimum channel spends, budget caps, and brand safety rules. Let's walk through the functional requirements. First, the engine must connect to all marketing platforms and data warehouses: Google Ads API, Meta Marketing API, Adobe Analytics, CRM systems, and offline sales data. Second, it must ingest granular performance data including impressions, clicks, costs, conversions, revenue, and customer lifetime value with proper attribution models. Third, it must build and maintain predictive models for each channel that forecast expected ROI based on spend level, seasonality, competition, and market conditions. Fourth, it must run optimization algorithms that allocate budgets across channels to maximize total ROI, while respecting constraints like minimum spends, caps, pacing rules, and brand safety. Fifth, it must provide real-time budget pacing alerts, performance monitoring, and what-if simulation capabilities for marketers to understand recommendations. These 5 capabilities make the engine actionable, not just analytical. Now the non-functional requirements. The optimization engine must be near real-time. Budget recommendations should update within minutes of significant performance changes. The predictive models must be accurate, because poor predictions lead to wasted spend or missed opportunities. The optimization algorithms must be fast enough to run continuously for large enterprises with hundreds of campaigns and channels. The system must scale horizontally to support multiple advertisers and billions of data points. Data freshness is critical because marketing conditions change rapidly during peak seasons. The system must be secure since it handles sensitive budget data, API credentials, and competitive intelligence. And finally, it must be highly available because marketing campaigns run 24/7 and budget decisions cannot be delayed. Here is the high-level system architecture. On the left, data collectors ingest performance data from marketing platforms via APIs, webhooks, and data warehouse connections. These events flow through a load balancer into a Kafka ingestion layer. A stream processor validates, enriches, and stores the data in a data lake and analytical databases. The model training pipeline continuously updates channel-specific ROI prediction models using machine learning. The optimization engine runs allocation algorithms that consider current performance, predictions, constraints, and business rules. The recommendation service serves budget adjustments to marketing platforms via their APIs. A monitoring dashboard provides real-time visibility into performance, pacing, and optimization decisions. An alerting system notifies marketers of significant changes or issues requiring manual intervention. The key metrics to memorize cold. Overall ROI percentage, total revenue divided by total marketing spend. Cost per acquisition by channel, showing efficiency across different platforms. Return on ad spend trends over time, indicating optimization effectiveness. Budget pacing variance, how actual spend compares to planned spend over time. Attribution accuracy, measured by incrementality testing and model validation. Model prediction error, typically mean absolute percentage error for ROI forecasts. Optimization lift, the percentage improvement in ROI after implementing recommendations. And constraint satisfaction rate, how often the system respects business rules while maximizing ROI. These metrics are what marketers and executives actually care about. Let's trace the end-to-end user journey. A marketing director at a retail company opens the ROI Optimization Engine dashboard at the start of Q4. The system shows current ROI at 3.2x with a projected optimization opportunity of plus 18% if budgets are reallocated. She sees that Google search is oversaturated with diminishing returns, while TikTok and connected TV are underutilized with high incremental ROI. The engine recommends shifting 15% of search budget to emerging channels while maintaining minimum brand safety spends. She runs a what-if simulation showing the projected impact and approves the recommendations. Within minutes, the system updates campaign budgets via platform APIs. Over the next week, she monitors performance as the system continuously fine-tunes allocations based on real-time data, ultimately achieving a 3.8x ROI for the quarter. The core models and algorithms. Attribution models assign credit to touchpoints using first touch, last touch, linear, time decay, and data-driven approaches. Incrementality testing measures the true lift caused by marketing spend through geo-testing and holdout groups. ROI prediction models use regression, time series, and machine learning to forecast returns at different spend levels. Budget optimization algorithms solve constrained optimization problems using linear programming, gradient descent, or genetic algorithms to maximize ROI under constraints. Seasonality adjustment models account for periodic patterns, holidays, and market events. Competitive bidding models anticipate competitor behavior and market dynamics. The key trade-off is exploration versus exploitation, testing new channels versus doubling down on proven performers. Another challenge is balancing short-term ROI with long-term customer lifetime value. Now the low-level design deep dive. The data pipeline uses a Lambda architecture with batch processing for model training and stream processing for real-time optimization. The feature store stores engineered features like historical performance, seasonality indices, and market signals. Model training runs daily using Spark ML or TensorFlow, updating channel-specific prediction models. The optimization service runs every 15 minutes, solving the allocation problem using a custom solver that handles nonlinear ROI curves and constraints. The recommendation queue buffers budget changes and applies them gradually to avoid market disruption. The state store tracks current allocations, performance metrics, and optimization history. The API gateway handles authentication, rate limiting, and integration with marketing platform APIs. For large enterprises, the system supports multi-tenant isolation and hierarchical budget management across brands and regions. Key takeaways for your interview. First, an ROI optimization engine is a prediction and optimization system, not just a reporting dashboard, so emphasize machine learning models and constrained optimization algorithms. Second, always discuss attribution models and incrementality testing, because ROI calculations are meaningless without proper credit assignment. Third, real-time optimization requires balancing model accuracy with computational speed, so be ready to discuss trade-offs between complex models and fast decisions. Fourth, the hardest design challenge is handling nonlinear ROI curves and constraints in the optimization problem, so mention linear programming approximations and heuristic approaches. Fifth, integration with marketing platform APIs and respecting rate limits is critical for real-world deployment, so discuss API management, error handling, and gradual rollouts. If you can walk through this system with these 5 points, you will signal strong senior-level design thinking. That's it for the Marketing ROI Optimization Engine. If this helped, like and subscribe, and I'll see you in the next one at Cloud Wizard. And that's a wrap on the Marketing ROI Optimization Engine. We covered the full picture, from data collection and predictive modeling, through optimization algorithms, real-time allocation, and platform integration. If this video helped you, please hit that subscribe button and the bell icon so you never miss a new system design video. Drop your questions in the comments below. I read every single one. See you in the next one at Cloud Wizard.